So BGP stands for Border Gateway Protocol. BGP stands for Border Gateway Protocol. It's a Border Gateway Protocol. BGP stands for Border Gateway Protocol. Don't confuse it. If they'll it is a Border Gateway Protocol and it is a open standard protocol. BGP, it is a open standard, and this BGP will use at all the switches, all the routers, entire and different vendors also, like HP, Aruba, and different vendors. Aruba or Palo Alto, FortiGate, entire vendors will use, and Cisco also. Cisco, and apart from that, non-Cisco devices also will use BGP protocol. Actually, it is a eGP protocol. Earlier, what we discussed, those are the IGP protocol. Now, BGP, it's a eGP protocol. eGP stands for Exterior Gateway Protocol. And earlier we discussed like IGP protocols. Those are the, like, we have the within a LAN, when within a LAN we are using the IGP protocols within a LAN. Those are the our OSPF and EAGRP RIP protocol. Apart from that, ISIS also. These all are the IGP protocols. Now move to the eGP protocol. What does it mean? Will use a two different AS number. Two different AS number devices can do the communication with each other. Means this is the different AS. You can assume like 100 here, and here AS is 200. Different AS, different ISPs, two different ISPs, two different organizations, anywhere, two different AS numbers will use as a BGP protocol. So that is the reason it is a exterior gateway protocol. It is a exterior gateway protocol. That is the reason. We'll discuss more about it. And what does it mean? AS number, autonomous system number. AS stands for autonomous system number. Who will provide it? Actually, AS number, who will provide it? Who will provide it? IANA will provide the AS number, Internet Number Assigned Authority. IANA will provide the AS numbers. Internet Assigned Number Authority, responsible for allocating AS number, and ranges we have like from 0 to 655, 65535, the range. Who will the AS number only, the IANA only, regional internet registries, the organization, they will provide to us. Sub-organization of IANA, and manage AS number. This organization only manage the AS number. And we have the AS numbers between, these are the public AS number 1264511. This is the public AS number. So we should have to buy public AS, means public IP, like public IP addresses only. Like this is the private IP ranges 64512 to 64535, the last range. From starting range is 64512 to 65535. The range ends with. This range only will use at our organizations. Like this is a free of cost. No need to buy from IANA. No need to buy from IANA. This is a free of cost. Yearly, if you are taking this range, yearly we should have to pay to them. Yearly. Like domain name, whichever .com, .net, whichever we are xyz.com, whichever we are taking domain names, yearly it will be rented. If you are not paying after 1 year, it will be lost your domain. Other persons can buy it. Likewise, we should have to buy from IANA, AS numbers also. This is a free of cost, and we no need to worry about it because of whenever we are taking the service from ISPs, this is, you can assume ISP, the ISP is responsible to us, they will provide to us this service. ISP is provide to us. In our organizations, we'll use this range. We'll use mainly this range. And the AS concept is, the AS number is every organization must they will use. Like Wipro, like any companies, you can assume IBM, Wipro, whichever companies, whichever the big size of organization, they'll must use. Even though government organizations also they will use. Because see, without BGP, we cannot reach internet. If BGP is not there, we cannot reach the internet. Because see, the one of branch is your at one location, another branch is at another location. So in a between, the ISP is not there, we cannot communicate. This is our LAN, this is our LAN. One of the branch is India location and one of the branch at US location. India location and it's a US location. In between, if ISPs, in between multiple ISPs will work. If you are in India location, we have a BSNL, we have a Geo, we have a Airtel, multiple BSNL ASPs are there. And US locations, AT&T, Verizon, this kind of AT and NT. So many ISPs are there. Those are specified in location based. So here the different ISP and here the different ISP. So ISPs, they will use the public AS numbers. In this range, they will use mostly. In this range, they will use public range. Sorry, this is the public range. It is the entire range. This is a public range, they'll use. ISP guys will use this range. And even though if we required, ISP guys also, they will provide to us AS numbers. And if you don't want, then if you are the company of like whichever we are the XYZ company, XYZ, and here also we have the XYZ branch. So our XYZ mainly we are using like 64,512 and 64,512. We can use this is the free of cost. We can use this is a free of cost. And in between AS number, it will be moved to the likewise. They'll use here. We have a concept like whenever we are using this same AS number, then we'll use iBGP, Interior Gateway Protocol, Interior Border Gateway Protocol, Interior BGP. I'll explain those things. Before that, just I'm giving the brief about it. And here the different AS, you can assume this is 100. ISPs are private, they are using public AS, that is 100. So this iBGP to, here we have a different AS number, here different AS number, here different AS number. So in between we'll use eBGP, exterior border gateway protocol. Actually, two types of neighborship will apply here. One is iBGP and one is eBGP. We'll more discuss about it. Before that, just I am giving the brief introduction how it will be work BGP mainly. So it will be work based on the AS number. If BGP we are not using at our LAN location, at our branch location, we cannot reach to our different branch. So BGP is the only protocol to communicate two different locations. BGP only the protocol to communicate two different geographical locations, two different branches, two different companies also, two different companies also. You can assume this is a IBM company wants to communicate. IBM company wants to communicate Wipro. Then BGP is required here because they have a customer, they have a clients, like here the manager is there and this is a manager of Wipro manager. They both wants to communicate at one-to-one communication. So here also required the BGP. So if we want to reach the internet, if we want to reach the geographical locations, the without BGP, we cannot reach the different locations. So that is the reason the BGP is required. I hope the requirement of BGP, everyone got it. I'm deleting. Any doubts in these scenarios, in this BGP protocol uses? Yes or no?
No.
Fine. And BGP, it is a path vector routing protocol. Means it checks path attributes to reach the destination, not any, it will be not used like earlier we discussed the OSPF protocol, eIGRP protocol. eIGRP and OSPF as well as RIP also will use the best path selection purpose. They'll use like metric. But here in this BGP protocol, it will use the path vector. It is a mainly path vector routing protocol. It is a path vector routing protocol. What does it mean? Means it check path attributes to reach the destination, not any metric like IGP protocols. Means here we have the weight, local preference, AS numbers. Those are the path. If mainly, so here we have a multiple path. You can assume this is our destination from its source IP address, and this is a destination, your location. We have a different path to reach. This is the ISP1, you can assume, ISP2, you can assume, and ISP3, you can assume. We have a different ISPs. Likewise, we have a path. So here we are using 1 gig link, and here we using 100 Mbps link, and here we are using 10 Mbps link, MB, and 100 MB, and 1 gig link. So uh, compared to these two links, this is the best part. This one is the best part. So in this case, I can use as a best path this one. So we have the local preference and weight, and we have the path attributes. Path attributes, with the help of that path attribute, I can manipulate the path, whichever we require, whichever we need. I can manipulate the path, whichever we need. If this path is goes down, then it won't elect as a second best path, because in this BGP, it is not a dynamic routing protocol majorly. It's not a dynamic routing protocol. BGP is not a dynamic routing protocol. Statically we are configuring the neighbor. Statically we are configuring the neighbor. Don't confuse it. Statically we are enabling the neighbor. Statically I'll show you in lab. So BGP, whenever we are configuring, your neighbor is this one. Your neighbor is this one. And directly we can enable the neighbor this to this, R1 to R2. In between, how many routers are there? No need, not much more. Just reachability is there. We can create the neighborship in between. We can create the neighborship in between. Just we need a reachability with the help of any default, use any default routing, use any static routing. With the help of, you can enable direct neighborship from R1 to R2. In between, multiple routers also are there. No need to configure it. Just reachability is there with the help of static routing, default routing, use any OSPF routing protocols also. We can enable statically, we can create the statically neighborship. That is the reason the BGP, it will be reached one geographical location to another geographical location with the help of ISPs. Guys, I'm going slow. If you are getting any doubts, ask me in between. What is the reason why we need? And it is a layer 7 protocol. Yesterday we discussed OSPF and EAGRP. Those are the layer 3 protocols. Those are the L3 protocols. Which one? OSPF and EAGRP. EAGRP. And RIP also layer 7 only. The RIP also layer 7 protocol only. It is legacy protocol actually. Nowadays we are not using. We are using like this also, a 20% organizations are using, and but 80% of organization for IGP protocol, that is we are using like OSPF. So L3 protocol, these are the L3 protocols. That is the reason they have the multicast IP address. Again, one more thing, EAGRP and OSPF, we have a multicast IP addresses. But in BGP protocol, we don't have multicast IP address. Here we don't have multicast IP address. Reason behind, I'll explain those things. But BGP, it is layer 7 protocol. It is layer 7 protocol. And BGP use the port number. It is say use the port number because with the help of port number only will identify the service. We will identify the service. So the port number is 179 and it uses a TCP port protocol, TCP port number, TCP protocol with port number. That is 179. Where it will be work? Layer 4 in OSI model. So what is the requirement of that? See, we have a two neighbors. They are connected likewise. And whenever R1 and R2 in between, we enable BGP protocol. So first, and BGP is a reliable protocol. That is the reason reliable means it will be used three-way handshake. BGP will use three-way handshake because of it is a reliable protocol. It is a reliable protocol. So it will be used three-way handshake with the help of TCP port number 179. So we'll discuss here now what is the TCP three-way handshake. General discussion TCP, what it will be sent whenever the send, it's you can assume R1 and R2. R1 as a server, R2 as a client. The server send a one sync packet in between. It will be originating, it will be creating the reliable connection in between two routers or two client to server, you can assume. So R1 is sending sync packet, and R2 whenever the receiving, then it will be giving the reply like sync plus ACK, acknowledgement. So once it will be received, then it will be give the acknowledgement. I got your information. It is kind of reliable connection. It is a reliable connection. So BGP also work likewise. So that is the reason here we don't have multicast IP address. Apart from that, here whenever we are creating neighbor, that time also statically we are enabling neighbor. Statically we are configuring. So whenever the neighborship is formed dynamically, they should have to send with the help of 224.0.0.5 or 6 or 10. This is the multicast IP address of eAGRP. This is the OSPF. So here we don't have any multicast IP address. How they will form? With the help of unicast. Unicast. One-to-one communication will be happen. So here the load balance also not there. In BGP protocol, the load balancing also not there. The one-to-one connection it will be established. So that is the reason the whenever the sending the packet, now coming to sending the packet, it will be in layer 4. What it will be happen? Whenever the connection will be establishing, first it will be sent with the help of port number 179. Whenever the 179 port number it will be receive R2, it will be assume the packet is coming from BGP. Then the neighbor establish it will be happen. Then it will be give the port number randomly. It will be select any port number 1024 or something. It random port it will be select. Then establish the connection in between two routers with the help of 179 port number, and it will choose any random port number. Whenever establishing the connection, that will be established with the help of 179 port number, and whenever the giving reply, that time it will be give the reply any random port number with the help of 1024 or 1025 something, any random port number. It will be establish the connection every 60 second. They will send keep alive messages every 60 second. If this three message not giving the reply, if neighborship went down, it will be originate three keep alive messages up to that is 3 minutes. Means 180 seconds. If 180 seconds, this router to R is not giving with the help of port number of 1024 with this port number reply, unicast reply, then neighborship is down. It will be wait only this router will wait 180 second. After 180 second, the neighbor is not receiving any reply through R2 with the help of port number. Whenever the establishing neighbor, the port number, it will be stored in BGP database. BGP database, the port number, entire thing will be stored. What we're discussing here, open message. This is all is the open message and update message. It will be stored, entire thing. If it will be not received, it will be wait for 180 seconds, then neighborship will be down. Once this router again it will come back to up, then again it will be send sync packet. Shall we start reconnect? Then it will be send sync ACK. Then it will be once this router will get the sync ACK, then it will give the acknowledgement. Likewise, the unicast message they will send. Here, the multicast concept is not there because we are originating the who administrator will be originating the neighborship. Here, administrator originating the neighborship. That is the reason the BGP having only one path away routing protocol, one hop away routing protocol, where in BGP directly connected interface and indirectly connected interface with the help of loopback also we can enable the routing, we can enable the neighborship, indirect neighborship, that is indirect neighborship, and direct neighborship means directly connected interfaces. I'll show you in lab that thing. But BGP is the only protocol. It will be maintained lakhs of prefixes, not thousand prefixes. IGP will maintain the thousands of prefixes. If here you are using lakhs of prefixes in OSPF or EAGRP, the neighborship will be not perform well. Those routing protocols not performing well. If you are using BGP protocol, here you can use a lakhs of prefixes. In BGP protocol, lakhs of prefixes. Understood? Yes or no? And mainly it is reliable protocol. BGP is a reliable protocol. That is the reason. It is reliable protocol because of TCP protocol. It is a TCP based protocol. And it is a classless routing protocol. What does that mean? Classless. What does it mean? Classless routing protocol.
Uh, it
If
carries
right or
the
wrong?
permission and the subnet mask.
Yes. It will be carry the subnet mask, whichever 17 or /25 or /28, entire thing. It will be carried with subnet mask. That is the reason classless routing protocol. It will be FLSM, use FLSM, fixed length subnet mask, and VLSM, variable length subnet mask. It will be support both. That is the reason it's a classless routing protocol. By default, load balance will disable in BGP. If we want, yes, we can do it. We should have to enable through command. If we want, we can enable it through command. Where we'll use BGP load balancing actually, if we are using a multiple ISPs, if we are using multiple ISPs at our different location, we have a branch. So we have connected likewise ISP1 and ISP2. This is a one ISP and this is a second ISP. So here we are using 1 gig link and we are not paying much for this link. Even though for redundancy purpose we are using. We have a multiple clients here, multiple customers we have. And here we have a multiple customers we have. So this is a MB link, and so important business data, important business traffic will pass on this way, and entertainment traffic like YouTube or Facebook, those traffic will pass on this way. We can use load balancing on those scenarios. Yes, we can enable with the help of commands. By default, the load balancing will be disabled. When the scenario, if the requirement is there, is the great example is business traffic will enable this path, and some entertainment traffic will enable for this path. So business hours not required for entertainment traffic. So that is the reason if we can enable likewise. And here we discussed, we have a IGP and EGP protocols. We have a two neighborship we can enable in this BGP. So whenever you are using, so eBGP and iBGP, the AD value is must and should. The administrative distance value is must and should. Because if AD value is not there, the neighborship will not establish. So routing path, it won't calculate. If you are using with the help of AD value, it will be elect the routing table. So here we have two AD values and two because of IGP internal prefixes for IGP. This is iBGP purpose. We are using 200, and eBGP prefixes part we are using eBGP. Exterior border gateway protocol and interior border gateway protocol. It will be used mainly at our land location, and it will be used in between two branches. In between, where we'll use iBGP and where we'll use eBGP. At land location, we'll use iBGP. Why we need iBGP? Again, we have a IGP protocols. IGP protocols also we have. But IGP protocols, as I mentioned, it will be carry the only thousands of prefixes. But BGP protocols will carry the lakhs of prefixes. So that is the reason we are using IGP protocol. It will be used, AD value is 200, and in between two different AS will use as a eBGP protocol. eBGP protocol. So in between we should use eBGP and eBGP here. That will be used 20 AD value. 20 AD value. So we have a two AD values in BGP protocol, that is 220 and 200. 200 for the internal prefixes, that is iBGP, and 200 for the iBGP, 20 for the eBGP. Any doubts? No. As we discussed these points, just I'm giving the reference. We discussed these points. In case of BGP protocol routers send all Unicode messages towards each other because there is no concept of multicast. There is no concept of multicast IP addresses. They will send unicast messages only towards each other routers. BGP does not support dynamic neighborship. And as I mentioned, it is not support dynamic neighborship. We cannot enable dynamic neighborship. Just with the help of in OSPF or eAGRP, just with the help of enable the router OSPF uh, process ID, then we'll advertise any network in between two routers. Just we enable the with the help of router command, router OSPF, and we'll use like any network command. With the help of network command, just we enable the uh, dynamic neighborship in between, establish the neighborship. If we have multiple routers also, is dynamically it will be established the neighborship. But in BGP, we should have to tell manually your neighbor is R2, your neighbor is R3, and your neighbor is R4. We should have to enable statically. I'll show you in lab, but we should have to enable statically. It will not support dynamic neighborship. If someone asks you dynamic neighborship will form at BGP, no, the answer is no. We should have to create a manually. We should have to manually. We should have to statically. We should have to create it.
Like we have to give enter IP address.
Yes, enter
Okay.
the IP address. So statically we should have to enable. How will I'll show you in lab that thing with some commands are there. I'll show you in lab for that. Don't worry. We can only form static neighborship between the routers. BGP can maintain lakhs of prefixes inside the routing table. Is inside the routing table, it will be maintain the lakhs of prefixes. That is the reason the BGP is only the protocol where we are using it between the two branches. BGP can maintain lakhs of prefixes inside the BGP table, whereas other IGP type routing protocols can maintain thousands of prefixes. This point is very important. So mainly where we'll use BGP routing protocol? Why we require the BGP protocol concept and which customer type will use? If we are using enterprise network means it's campus network. You can assume like we have a multiple thousands of branches, hundreds of branches. Our office is corporate office, MNC, that time we can use. And to make communication possible between two ISPs, like whenever we are discuss, as I told you, we have a branches like different geographical location. So in between multiple ISPs will work. So because see, in India location, the different ISPs, and in India location, the different ISPs, in US location, you can assume different ISPs. So that is the reason in between AS numbers also will use BGP protocols. And we have a customer types. I'll explain those things. Before that, these 2 points you understood. Enterprise network and between two different ISPs. This is India location, IND, and here we are using like Geo, and Geo we are using ISP, and US location you are using like Verizon or AT&T. AT&T. There you cannot find out the Geo, right? In US location. In India location, we cannot find out the AT&T likewise. So that is the reason in between ISPs will use the concept that is BGP. So here different AS number is 100, here 200, here 300. So in between different AS, whenever you are seeing the different AS, so definitely you will assume there we are using eBGP protocol, eBGP neighborship we are using. When you are seeing the same AS, here we are using 10 for this router, and we are having this is the LAN location. Here we are using 10, and we have a one more router that also 10. AS number is 10 and AS number is 10. If you are seeing same AS, that is IGP neighborship, iBGP neighborship. If you are seeing different AS number, that is that eBGP neighborship. We established in between two different AS, that is eBGP neighborship. Same AS, that is iBGP neighborship. In simple, iBGP interior, eBGP exterior. Don't confuse it. Do you have any queries till? Before we'll move to the network customer types. If you have any queries, ask me. We have a different customer types here, types of customers. So third one is customer type. We have a single homed customer, dual homed customer, single multi-homed customer, and dual multi-homed customer. First, we'll discuss single homed customer. Here, single homed customer. This is what LAN location. And connected to one ISP. Single homed customer. They are connected likewise. And we have a LAN here. This is a LAN and this is a WAN connectivity. So we have a multiple prefixes here. So it's a kind of single homed customer directly connected to ISP. When in this case, not required the BGP also. If we want, you can enable it on the waste of resources only. If you are enabling waste of resources, if you have the multiple means prefixes, we have lakhs of prefixes, that time you can enable it. We can just give the default routing. If we are using default routing in between with the help of 0.0.0 and 0.0.0 subnet mask and give the next hop of IP address as this one, then it is possible. The single homed customer not required also. If you want, you can use it. This is a single homed customer directly connected with one ISP. What about dual homed customer? We have a redundancy routers. We have a redundancy routers. You can assume no. We have a two ISPs, you can assume. The ISP is connected likewise. It's a dual homed customer. It's a single homed, and this one is a dual homed customer. And the R1 here we have a redundancy path. One link goes down, then we have a redundant link. This is a dual homed customer. In this case also, if you required, we can use it. Otherwise, not required also. Because if one link goes down, we have another link. Just use default routing or static routing in between. In this LAN location, we have a multiple prefixes. You can assume just use as likewise. We have a redundancy link. Then what about single multi-homed customer? These are the customer types. In BGP, we have a customer types actually. So what about the single multi-homed customer? Third type, single multi-homed customer. We have a one IS only in between only one ISP. Likewise, R1 and R2. If this router is goes down, we have a issue. If here we have a two routers at LAN location, we have a two routers, and these two routers connected to one switch, core switch, you can assume. If this router also goes down, we have another router. It's a single multi-homed customer type. If we have this router goes down, we have another router. That is called single multi-homed customer type. This is the customer type where we'll use likewise in customer in your working environment. Likewise, you will see in real time two ISPs with one router, one ISP with one router only, one ISP with two redundancy path. Otherwise, we have a final condition. Here, the BGP is required. Again, here we need a BGP for path manipulation. And we'll use here FHRP routing protocols also. One router, one FHRP, hard standby redundancy routing protocols. So we have another path, that is this one is a third method, and this is the first method, and this is second method, and fourth method is we have here dual multi-homed customer type. So we have it here also 12, sorry, 12 multi-homed customer type. We have two customer types. Here we have two customer types and two ISPs with two routers, and these two routers are connected our LAN location. Likewise, for connectivity will happen. LAN. This is the LAN. Here we'll do path manipulation, entire thing. This is a data center we'll use. In data center locations, we'll use this kind of scenario, this kind of customer type, and branch location will use likewise. In branch locations, this type or this type, at branch locations. But this is in this case not required the BGP. If you are using also no issue. But we have a 4 types of customers, that is single homed customer and dual homed customer, and third one is single multi-homed customer, and fourth one is dual multi-homed customer in BGP. We have a 4 customer types. Data center will use this kind of. In data center, in branch locations will use this kind of customer type. Any doubts? Yet in customer types?
In this, where we use BGP, sir, like in these 4 types.
Yeah, see. This is your ISP, right? This is your ISP router. Fine, good question. This is our ISP, Internet Service Provider, and this is the branch location routers. So ISP uses AS number, that is you can assume 100. And here our branch location, those routers are using AS number is like you can assume give the 55,000. Can I use likewise in between which ranges we have, like as I mentioned is 55,000, it's not free, and 65,000 will use 65,000 6,555 you can use. This is the range we can use free of cost. So here we are having the again AS is 65,000 65,000. In these two interfaces, we'll use eBGP protocol. In these interfaces, we'll use eBGP protocol. So what about this? What about these LAN prefixes? In this LAN prefixes, we'll use IGP protocol, any IGP protocol. IGP protocol. So in this IGP protocol to BGP protocol will redistribute. We will redistribute means what about redistribution? Redistribution is a method to transfer the prefixes IGP to BGP, BGP to IGP, transferring. Just we are transferring. I'll show you in that lab. I'll show you. I'll decided to show today itself. In between this interface to this interface, will use mainly BGP protocol, and in between this prefix to this prefix, will use eBGP mainly. eBGP, and here we'll use eBGP. And what about here IGP? Otherwise, you can use iBGP also. iBGP. We have a two neighborship, right? So iBGP same is. What is that? 65. This is the AS number in between. If you want, I'll explain that more about that. This is a core switch, right? Core switch, we can enable the routing also. Core switch, what it will do, we can enable the routing also. So in these interfaces, in between the interfaces, we can use the IGP protocol also. IGP protocol, iBGP protocol also. If you want this protocol also. If you have multiple LAN prefixes, so here you can use any OSPF or something. But in between ISP to our customer edge, this is a C edge router, customer edge router. This is, we call it as a provider edge, PE, provider edge, PE. This is a P and edge, provider edge, PE. Customer edge to provider edge will use eBGP, and customer locations will use iBGP. Okay, got it? Anyone? Any doubt in these things? Where we'll use BGP mainly? In between we'll use.
What about the AD values if we are moving from eBGP to iBGP? Will they change?
No, it won't change. It is the by default values actually. This is the AD value is 20, and the AD value is here 200. See, now tell me, actually 20 is bigger than OSPF, right? OSPF AD value is how much?
110.
110. So bigger than this, though so routing table will elect as a this path is the best path. It will be elected as a best path. Understood? Even though if you are configuring iBGP, that is OSPF, and iBGP also, iBGP and OSPF and two routing protocols, you advertise the prefixes. it will be take as a best path OSPF only based on the OS metric value, AD value, based on the AD value. We'll discuss more about it. But when we are using the AD value, that time, if you are enabling two routing protocols, that time it will be elected which one is the lesser value, less AD value, it will be elected. That is the, it will be stored in routing protocol. That is the best path. AD value is constant. Whenever you are moving, if you are using here AD value is 20 compared to if you are using any OSPF or any protocol, so 20 is lesser than that. So it will be elected that based on that only eBGP protocol. Got it, Jyoti?
Yes, my question is from ISP to router, it will be having OSP. It will be having 20 AD number, and from here to here, if you are using OSPF and IGP, it will be having 120 AD value. Why?
110.
Because as we are saying 110. Why? Because we are saying based on the lowest number it will take. So here the
Right.
lowest number is 20. So it will take here, and the lowest number here is 110 out of 65,000. So it will elect OSPF.
No, 65,000 is not a AD value actually, Jyoti. This is the AS
No,
number,
sorry, 200.
autonomous system.
200. So, sorry, 200.
So yes, yes.
Mm.
Yes. If you want, you can change the AD value also. You can decrease the AD value, whichever you need. If you want, you can decrease the AD value also. That is with the help of command, we can do it. This is all about customer type, and here we have single homed customer, dual homed customer, single multi-homed customer, and dual multi-homed customer. And here we have a message types. Types of messages in BGP. Open message, keep alive message, update message, and notification message. Where we'll use basically whenever in between you enable the BGP protocol. In open message, TCP connection will be established. In between, TCP connection will be established with the help of open message. Of sync packet and sync acknowledgement and sync act with the help of 179 port number. It will be give the reply any port number 124 something. The unicast messages it will be sent, and after then it will be sending keep alive messages. 3 keep alive messages. The once you enable both end BGP, then it will be give the reply. In that reply, it will be give the entire prefixes with the help of update messages. If he have this router having the multiple prefixes information, it will give in that update message entire routing information in update message. We have open message. Once you enable both, and it is kind of hello message in EAGRP visa and OSPF visa, hello message, right? Hello message. Same hello message. Likewise, here we have the open message. Open message. In this open message, they both can send and receive the neighborship parameter, whichever version, router ID, entire thing, it will be sent and received in this case, message. And keep alive, the keep alive every 60 seconds, it will be sent of my neighbor is up or not. My neighbor is up or not. My neighbor is down if not, and not reachable, then it will 180 second it will be wait. Then after then it will be moved to the down state. So in update message, it will be send the entire prefixes whatever he have. And notification message. If any changes occur in topology, if any changes, new prefixes, new things, any topology changes occur, any neighborship issues, it will be sent with the help of notification message. There we have 3 types of messages, 4 types of messages: open, keep alive, update, and notification. And after this is the first message, and second message, and third message. Keep alive after the neighborship form in between two routers. That is the reason I mentioned here fourth one. It will be work like every 60 second. Every 60 second, it will be send keep alive messages. You are available or not? You are alive or not? You are available or not? Router 1 is sending to router 2, you are available or not. Every 60 seconds, it will be sent the neighborship message. This is the types of messages. Got it? And whenever the neighborship is forming, it will be form likewise move whenever the neighborship forming, we have a states. Will be go through one by one state. First one is ideal state. Then second one is connected, active, open send, open confirm, and establish. We have a 2 routers, R1 and R2. R2 with this having IP address is 11.1.1./24, and here we are having 1.1.1.2/24. So in between, you enable the with the help of neighbor command. What is my neighbor? Neighbor IP address is my neighbor IP address is help of router OSPF. This is the AS number is like 100, and here also AS number is 100. So with the help of neighbor command, AS number, this is the AS number, and this is the AS number. Here which BGP neighborship we are forming in between two AS, which neighborship we are enabling. Guys, which neighborship form in between two R1 and R2? iBGP or eBGP?
iBGP.
Router BGP 100 will use here the command. After then in this router config or one config likewise. This is a command config. This command after then statically we are enabling the router, right? As I mentioned, statically we are enabling the routing. How? And neighbor command after then neighbor after then use this IP address 11.1.1.1 after then remote AS is Likewise, 100. Simple. One side you enable, other side you are not enabled. That is ideal state. Both end you enable, they are trying to reach, they are trying to establish a connection. They are trying to establish a connection with update message, open message, sorry, hello message, that is open message they are sending and receiving. After then, once they receive and update, they'll move to the, they will send and receive the confirmation, open send and open confirm. After then, they will establish a connection in between. Establishment, finally, they'll establish. What about active? If anything is mismatch, something happen, neighborship is not formed in between, then it will be moved to the active state. Active means the neighborship is not formed in between. If you say active, you see active state, the neighborship is not formed. Whenever you see the established in between two neighbors, that time only neighborship is formed. Ideal state, connect state, both are sending and receiving the reliability connection. After then, active state means active state is not forming anything, error is mismatch is there. In between the subnet mask mismatch or MTU side mismatch, you did some mistake, then it will be moved to the active state. And after then open send, they will send and receive the packets or prefixes, something. After then, it will be moved to the established state. Established means connection is formed in between routers. Understood? Any doubts?
Can you repeat this again?
Fine. See guys, actually we have a types of states. Whenever you are configuring the BGP in between two routers, BGP in between two routers. So we have a command router BGP 100 and neighbor command. Statically, we are enabling the neighborship in between. Statically, we are enabling with the help of neighbor command. So this is not a dynamic routing protocol. As I mentioned, it is not a dynamic routing protocol. So statically, we are configuring the neighborship. So one side you enable, one side is not enabled. So it will be send open message to verify my neighbor is alive or not. If he is alive, we enable both end, then he will give the reply. If you are not enabled one side is enabled. That is ideal state. Ideal state means one side is enable and another side is not enabled. BGP protocol, that is ideal state. After then, once you enable both end, they together to form connect state. They are connected to each other. They will form. They will send and receive the unicast message. That is, with the help of 179 port number, they will send. Here we'll use any random port. For TCP port number. TCP port number is 179. It is a by default port number. They will establish the connection between two together with the help of connect state. They will entire thing is perfect. They will move to the open send message. In open send message, he will send his routing table and he will receive. He will confirm the routing table. Yes, I received your routing table. Then after then, they both will establish the connection in between with the help of final state is establishment. After then, if anything error is there, that it will be moved to the active state. Active state is means the neighborship is not formed in between two routers. The neighborship is not formed in two routers. If you saw active state means, if you see in here active state, the neighborship is not formed in between router state. It is something mismatch. something mistake is there. If established state, the neighborship is formed. Ideal, connect them together to connect, and open send, they open send and open confirm, they together they are routing information, they are sharing and establishing the neighborship. If something is mistake, it will be moved to the here active state. Likewise, it will be happen. Understood, guys?
Yes, sir.
Jyoti, got it?
Yes, for connect state from the R2 also we need to send the router BGP
Yes,
100.
both end. Yeah, both end we connect, establish the neighborhood. Here R2 also use the same command, but in this R2 you use here neighborship time 1.1.1.1 and remote AS is 100. Once you enable this command, both routers, then they both connected together. Got it?
Yes.
But if it is fine, then quick overview. So BGP Border Gateway Protocol. BGP stands for Border Gateway Protocol. It is a open standard protocol and it is a eGP protocol. It will be work with in between two AS numbers and it is a layer 7 protocol and it is a path vector routing protocol. It is a path vector routing protocol means here we have the attributes like weight, local preference. Those are the attributes. With the help of that attributes, it will be select the best path. And it uses TCP port number 179 and it is a reliable protocol and it is a classless routing protocol. By default, load balancing is disabled and here we have the two AD values 20 and 200, 20 for the eBGP and 200 for the iBGP. In case BGP protocol router send all unicast messages towards each other because there is no concept of multicast IP address. Here we have a unicast messages, it will be sent because here we don't have the multicast and it will be support only BGP support static neighborship. Statically, administrator will enable the routing protocol, does not support the dynamic routing or dynamic neighborship. And statically we should have to enable the neighborship. And here we have the where we'll use enterprise. We have the big size of network, big size of enterprise. We have the multiple branches. So we'll use BGP protocol and it will be used in two different ISPs. We'll use mainly two different ISPs. And we have a types of customer types, single homewood customer, and we have a dual homewood customer, and we have a single multi-homed customer, and we have a dual multi-homed customer. This is a dual multi-homed customer. And we have a types of messages: open, keep alive, update, notifications. We have four types of messages: open, keep alive, update message, notification message. And we have a 6 states. We have ideal, connect, active, open send, open confirm, and establish. This is the message types. And I'll give you here some what are the, and mainly here we will use BGP will use 3 routing tables. Yesterday we discussed in OSPF also 3 routing table and BGP also will use 3 routing tables. Neighbor table, BGP table, and routing table. It's a global routing table and BGP routing table also, you can assume. And we have a BGP table that is show IP BGP. There we'll find out the valid prefixes, whichever the valid and best prefixes, that prefixes only we can reach. And we have the neighbor table. With the help of these commands, we'll check these 3 tables. And OSPF also having 3 tables, that is neighbor table and database table, and we have a routing table, global routing table, and OSPF routing table. And EAGRP, how? EAGRP. What about EAGRP? EAGRP also three tables. One is neighbor table, and one is topology table. Topology table. Another one is routing table. And OSPF also have three tables. One is neighbor table, one is database table, one is routing table. Here also we have three tables. 1, 2, 3. As I mentioned, for best path selection purpose, they will use path attributes, like path attributes. What those are path attributes here? Just I'm giving you the here. First one is next hop, and second one is wait, local preference, self-advertised, AS path, origin code, MED, metric like, and external over internal, IGP, cost to reach next hop, and oldest path, eBGP only will use this path, and lower neighbor router ID and lower neighbor IP address. This is the advanced concept, but for path manipulation and RIP will use hope count, right? Hope count will use RIP protocol. And we have a metric for the K values for EAGRP. Load, K1, bandwidth, load, delay, MTU size, reliability, K1, K2, K3, K4, K values for metric. And OSPF also metric as a cost, reference bandwidth. Metric as a cost here. Metric equals to cost, that is a reference bandwidth. That is reference bandwidth. That is a reference bandwidth is equals to 100 by interface bandwidth. Interface bandwidth. Now move to the EAGR. BGP will use next hop, wait, local preference, self-advertised, AS path, origin code, MAD, external over internal IGP, and oldest path, lowest neighborship. This is a path manipulation. It will be checked one by one, one by one, one by one, one by one. Here we have a likewise. It will be checked hop count for RIP. This is the OSPF. A reference bandwidth is equals to 100 by interface bandwidth. Interface bandwidth, here we have the serial for the 1.5 kbps, 1.5 mbps, sorry, 1.5 mbps, and Ethernet link having the serial link having the 1.5 mbps, MB, and Ethernet link having the 10 mbps by default value, and fast Ethernet having the 100 mbps bandwidth. And here we have the 1 gig having the 1000 MB. So here 100 by 10 means The reference bandwidth of Ethernet is OSPF is 10. So fast Ethernet is 100 by 100. So reference bandwidth is here 1. Likewise. Here this also, if 100 by 1000 means the value will come 1 by 10 means the value is 0 point something 1. So we'll not take it as 0 point something value. So we'll take it as a 1 value. The reference bandwidth is 1 gig link is 1 only. This is the reference bandwidth of OSPF, eAGRP, and RIP. But here we'll use the path selection in BGP based on the next hop, weight, local preference, and will path manipulation based on this also. That is the reason it's a path vector routing protocol. BGP is a path vector routing protocol. Got it? If you understood, we'll move to the lab now. I'll stop the recording.